Okay, in the last topic, we saw the first of our molecular bonds, the ionic bond that forms when two atoms, one gives up its electron completely to another. They both become charged, and then because those charges are opposite, they are pulled close together. Now, there are other kinds of molecular bonds that are also super important in biology. Let's talk about the first. Now, not all unbalanced atoms are willing to donate their electrons to another atom. Let's take a look at hydrogen here. Hydrogen has a proton and an electron, but that means it's got a one electron in its valence shell. It's an odd number and it's not balanced. Remember, atoms like to have things in even numbers, paired and balanced. So these two hydrogen atoms go into a bar, sit down, having a beer, and they're each complaining to each other. This one's like, I only have one electron. And this one says, oh, me too. Isn't it just a drag? And so they look over at sodium and chloride, who are making lovey eyes at each other at the bar. And this hydrogen atom says, hey, why don't you just give me your electron and then we'll both be happy? And this one's like, what? Why would I give you my electron? Because then I would have none. Why don't you give me your electron? And this one's like, well, no, I'm not going to give you my electron because then I would have none. So they puzzle on this for a little bit, and then it occurs to them that they could just share. And that's what they do. They get closer together and then they share the electrons, which means that both of these electrons are orbiting around this proton or this nucleus and also around this nucleus. As far as each one of them knows, they both have two electrons. They just don't always have two electrons at the same time. Now, because they are sharing the electrons in their outer shell or their valence shell, we call this a covalent bond. They are sharing the electrons in their valence shell. Now, atoms can share more than one pair of electrons. If we look at carbon dioxide, we have a carbon atom that's bonded with two oxygen atoms. And instead of just sharing one pair of electrons, they share two pairs of electrons. And when that happens, this is called a double covalent bond. So we have single covalent bonds like we saw with two hydrogen atoms forming H2 or the hydrogen molecule. And we have double bonds that we see here in carbon dioxide. Double bonds are stronger than single bonds. Covalent bonds in general are the strongest bonds that we have. They're much stronger than ionic bonds. Now, when atoms share electrons in their valence shells equally, we call this a nonpolar covalent bond. This happens when both atoms are roughly the same size. However, sometimes two atoms bond together and form a covalent bond, but they don't share the electrons equally. This happens when the two atoms are of different sizes. So here we have oxygen, which is a much bigger atom and has more protons, more positive charges, bonded with hydrogen, which only has one little teeny tiny positive charge. Now, the electrons are like, well, hydrogen, you're very nice and all of that, but, oxygen has 8 protons and we are so attracted to that. So the electrons spend more time orbiting around oxygen than they do going over here around hydrogen. And because they spend more time on one side of the atom, of the molecule, this end of the molecule becomes partially negative because the electrons are just here more of the time. And this is how we designate it. This is the lowercase delta, the Greek letter delta. Just looks like a number 8 that you didn't finish drawing. Now, because hydrogen doesn't get the electrons as often, the charge on this end is dominated by its proton, its nucleus, and this end becomes partially positive. So Because we are separating the charge, we say that this is a polar covalent bond. We use this term in the same way that you might say that certain issues in society polarize people. So if you bring up a controversial issue, people move apart because their opinions are opposite. So here we've got the opposite charges moving apart or moving to either end of the molecule, and therefore we have a polar covalent bond. Now, let's talk about how we draw these molecular bonds. When we have a covalent bond, we represent it as lines in a structural model of the molecule. So, water, for instance, you probably are familiar with how we write it like this, H2O. This is the molecular formula, and it just tells us how many of each atom are in the molecule. We have 2 hydrogens and 1 oxygen. This is a structural formula. It tells us how those atoms are put together, how they are positioned. So we see we have 1 oxygen, and we can tell from this drawing that it has a covalent bond to hydrogen and another covalent bond to another hydrogen. Same thing with carbon dioxide. CO2 tells us that we have 1 carbon and 2 oxygens. And if we draw the structural representation, then we can see that carbon has 2 bonds to oxygen and 2 bonds to another oxygen. Oxygen, the molecular oxygen, is 2 oxygen atoms, and we represent that like this. So, covalent bonds are always represented by a solid line. Ionic bonds, we don't draw any lines. We just say NaCl, put them together. We know that's a molecule. We don't draw a line because it is a weak bond, an ionic bond. All right.